California Bearing Ratio (CBR). California Bearing Ratio is a penetration test for evaluation of the mechanical strength of road subgrades, subbase, and base courses. It was developed by the California Department of Transportation. The test is performed by measuring the pressure required to penetrate a sample with a plunger of standard area. The measured pressure is then divided by the pressure required to achieve an equal penetration on a standard crushed rock material. Or we can say the test is performed by measuring the load required to penetrate a sample with a plunger of standard area. The measured load is then divided by the load required to achieve an equal penetration on a standard crushed rock material. So here on this slide, some description regarding the California bearing ratio test is given, and you can see here again the definition for the California bearing ratio, that is load required for a certain penetration of plunger divided by standard load for same penetration multiplied by 100. So California bearing ratio is reported as percentage. And in the CBR test we use the surcharge plates, and the surcharge plates are used on the mold to simulate the field conditions, and one surcharge plate represents 2.5 inches thick pavement, and the two surcharge plates represent 5 inches thick pavement. So CBR at 0.1 inch penetration or corresponding to 0.1 inch penetration, that is load required for 0.1 inch penetration of plunger in pounds divided by 3000, and that ratio is multiplied by 100. So 3000 pound is the standard load for 0.1 inch penetration in the standard crush available in the state of California. Whereas the CBR at 0.2 inches penetration, that is load required for 0.2 inches penetration of plunger in pounds divided by 4500, and then it is multiplied by 100. So here 4500, that is the standard load in pounds required for 0.2 inch penetration in the standard crush. We can define the CBR, we can write the formula of the CBR corresponding to 0.1 inch penetration and corresponding to 0.2 inch penetration in terms of pressure, and you can see this formula CBR, that is x over y multiplied by 100, and here x is the material resistance or the pressure corresponding to 0.1 inch penetration or corresponding to 0.2 inches penetration, and y is the standard pressure required for 0.1 inch penetration and 0.2 inch penetration respectively. So keep this thing in the mind that when you are using the pressure, so standard pressure corresponding to 0.1 inch penetration is 1000 psi, and standard pressure corresponding to 0.2 inches penetration, that is 1500 psi. So accordingly we can write the formula for the CBR corresponding to 0.2 inches penetration and corresponding to 0.1 inch penetration. And keep this thing in the mind that higher of the two values will be used for design, and usually CBR corresponding to 0.1 inch penetration is greater than CBR of 0.2 inches penetration. And one more point that you must keep in the mind, that if the CBR corresponding to 0.2 inches penetration is greater than the CBR corresponding to 0.1 inches, then in that particular test you will have to repeat the test. If by the second time you are getting the same results, then you can take the CBR corresponding to 0.2 inch penetration as the design CBR. So the basic thing is that higher of the two values will be used for the design, and that will be considered as the design CBR value. Now here on this slide you can see the pressure versus penetration curves for different materials, and this curve, if you just look at that, this one is meant for the standard crush. So here you can see that you are having the maximum, you can say, the pressure which can be applied, and you can say it's the best type of material that we are having. So that's why we are using this one as the standard crush in the determination of the CBR value. And these are the design curves, and you can see that here corresponding to different wheel loads, and by considering the design CBR values we can determine the thickness of construction above that material by considering different wheel loads. So pavement design, California bearing ratio, CBR. So you can see that it is basically a penetration test, and you can see the schematic diagram for this particular test, and the penetration of 0.05 inches per minute, that rate is to be maintained. So corresponding to different pressures, different penetrations, we can note the pressure like this, or even you can note the load. So both models are acceptable, either we are considering the pressures or the load. So when you are having that set of information with you, so you can draw the curve between the penetration and the pressure. And here you can see the plot that along the vertical axis we are having the pressure. You can consider the load in pounds along vertical axis. So both models are being used, and along horizontal axis penetration in inches, so you can draw this curve. So this is very useful, and by using that you could be able to determine the CBR values at 0.1 inches penetration and 0.2 inches penetration. So to determine the CBR values for the 0.1 inches and 0.2 inch penetration, this plot is to be used, and we know this thing that the gold standard for CBR for 0.1 inches of penetration, we know 1000 psi pressure is the standard pressure, or you can say 3000 pound is the standard load corresponding to 0.1 inch penetration. And for 0.2 inches of penetration, 1500 psi is the standard pressure, or you can say 4500 pound, that is the standard load for 0.2 inch penetration. Now in this example you can see that for 0.1 inch penetration, this one, the pressure that you are having, that is 220 psi, and corresponding to 0.2 inches penetration you can see that you are having 300 psi pressure. Well, keep this in the mind that the standard material for this test is the crushed California limestone, this one. So we can determine the CBR values for 0.1 inch penetration and 0.2 inches penetration. So the pressure corresponding to 0.1 inch penetration, that is 220 psi, and the standard pressure is 1000. So in this way you are getting 0.22, so obviously 22%. Similarly for 0.2 inches penetration, the standard pressure that you are getting from the plot, that is 300 psi, the standard pressure is 1500, so this ratio is 0.2, and the 20% is the CBR value corresponding to 0.2 inches penetration. So obviously the design CBR value would be the higher of the two, and that is 22%. So The gold standard for CBR, as you know, for 0.1 inches of penetration is 1000 psi, and for 0.2 inches of penetration 1500 psi. So use 0.1 inches of penetration unless 0.2 inches is the greater value. If so, then rerun the test taking the higher of the two values from this second trial. So in general, the harder the surface, higher the CBR rating. So it means if the CBR value is high, it shows that you have got a very good material. A CBR of 3% equates to tilled farmland. A CBR of 4.75% equates to turf or moist clay. Moist sand may have a CBR of 10%. High quality crushed rock has CBR over 80%. The standard material, yes, this point is important. The standard material for this test is crushed California limestone, which has a value of 100%, obviously. Okay, if you just look at this plot, that is the load or pressure along vertical axis and the penetration along horizontal axis. So you are having this plot, and in this case no correction is needed. Now same thing you can see over here, we are having this shape in this case, and in this case no correction is required. But if you just look at the curves of other two materials, you are having initially a concave upward part. Look at that. And here the upward concave part over here. So when you are having the upward concave part in the beginning, then corrections are to be applied. Corrections are required. So what we do, we just draw a tangent over here, and in this way 0 will be shifted from this point to this. And if you just look at this one, here the tangent will be drawn, that is touching the horizontal axis somewhere here. So 0 will be shifted from this point to this. So now this will be the 0. And from this 0, considering the scale that we are using along the horizontal axis, so 0.1 will be somewhere here, 0.2 somewhere here, and 0.3 will be somewhere here. So by using the new scale, we will determine the load or pressure corresponding to 0.1 inch penetration and 0.2 inches penetration, and in this way we can determine the CBR values. So pavement design using the CBR values. So we need CBR values. Obviously we will have to evaluate the type of use expected wheel load during service, types of materials available for the construction. So these are the important aspects that you will have to consider when you are going to design your pavement by using the CBR values. And the design curves for roads, these are the design curves that we can use. And here you can see that for different wheel loads, this is light traffic, medium traffic curve, and this is heavy traffic curve, and corresponding to design CBR value, we can get the thickness of construction above that material. So keep this in the mind that these design curves will give you the thickness of construction above that material that you have tested in the CBR test. For example, if you have determined the design CBR value of the subgrade, so it means you will be getting the total thickness above the subgrade. So obviously that is the thickness, the total thickness of the pavement. And if you have got the design CBR value of subbase, so in that particular case you will be getting the thickness of construction above the subbase. As you know, above the subbase you are having the thickness of base and surfacing. And if you are, so in this manner you must stick to this idea that the design curves will give you the thickness of construction above that particular material which has been tested in the CBR test. So these design curves are used for roads, and these are the design curves for runways, taxiways, apron, etc. The firm curves, you can see firm line curves, these are meant for the runways, and the dotted curves are meant for taxiways and aprons. So again, if you are having the California build ratio design CBR value, so you can get the thickness of construction above that material by using these design curves. Example: a compacted subgrade has a CBR value of 8%. What is the minimum pavement thickness if it is to support a taxiway pavement designed to support a 80,000 pound airplane? So this is basically the axle load, 80,000 pounds. So obviously 40,000 pound wheel load is to be considered in this problem. Well, the philosophy of the CBR method is that a point on the curve for a given CBR material represents the minimum thickness of pavement courses that will reside above it in order to maintain stability. So you can see that these are the design curves for the CBR method, and in this example we are considering the taxiway, and we are considering the 40,000 wheel load, so it means this curve is to be considered, this one. And if you just look at this thing, that the CBR of the subgrade, that is 8%, and we are considering the taxiway designs, and the wheel load is 40,000 pound. So you can see here that this is the CBR value, design CBR value 8. So just move like this, and now you are here on the curve of 40,000 pound wheel load for taxiway, and then move in this direction. So in this way you can see that the total thickness of construction that you are getting, that is 23 inches. So total thickness of construction is coming equal to 23 inches from the design curve. The mechanics of the design. If you just go through the statement of the problem again, a compacted subgrade has a CBR value of 8%. What is the minimum pavement thickness if it is to support a taxiway pavement designed to support a 80,000 pound airplane, that is 40,000 pound wheel load? So we have determined that that is 23 inches. Now some points have been added to the problem. What is the optimal or the best bearing surface thickness? And for that you will have to consult this table, and you can see here the wheel load that you are considering, that is 40,000. So in this case you can see that when the wheel load is more than 15 kips and it is up to 40,000 pound, the thickness required for the weighing surface, that is 3 inches. So from that we have got it 3 inches. The next point is that what is the optimal CBR value of upper 6 inches of base? Now as per this method of CBR, the top 6 inches of base is very important, and for that you can use this table, and you can see that this table will give you the CBR values for the top, or you can say for the upper 6 inches of the base corresponding to different wheel loads. So here in this case the 40,000 pounds or 40 kips load is to be considered. So you can see 40 kips is over here, 40 kips is also here. So 65 and 80. So you can say that 6 inches of CBR 65 to 80 can be used from this table, And then there is another point which has been added. What can we use for the remainder of thickness of base? For the top 6 inches, we are recommending the material which is having the CBR value from 65 to 80. If you want to remain on safer side, so you can opt 80, because higher the value of CBR, better is the material. So what can we use for the remainder of the thickness of base? That is the question, and we will solve this on the next slide. Well, if you just look at the cross section, so at the top we are having the wearing surface that is of 3 inches. We determine that thickness by using the table, and the top 6 inches of the base is having the CBR value of 80%. That means we are going to use the material for the top 6 inches of the base that is having the CBR values 80%. Now what should be the CBR value of this remainder or the remaining thickness of that? So you can see that this is the subgrade. Above the subgrade, we are considering this as the base. So normally in the CBR method, we are using the term base course, the base course which is provided directly above the subgrade. But we are going to provide the base course in layers. The topmost layer is having the best base material, and below that we will be having relatively inferior base material. So we just want to know the CBR for this part or this thickness of the base. Well, again look at the design curves. Well, from here you can see that need of 9 inches minimum thickness corresponding to 40,000 pound wheel load. How can you say this? Look at that. If you just look at this 40,000 dotted curve, which is meant for the taxiway, so you can see here it is 9 inches written. That is the minimum thickness. So this is the minimum thickness corresponding to 40,000 wheel load, and you can see here that corresponding to this minimum, I mean to say the minimum thickness, that is you are getting 9 inches. So this is 9 inches. So need of 9 inches minimum thickness corresponding to 40,000 wheel load. And corresponding to this point, you can see the CBR value, that is about 28%. So it means the remainder of base, that is 14 inches, we can take the material which is having the CBR value equal to 30%. So just rounding it off or just taking it as 30%. So we can say that remainder of base, that is of 14 inches thickness, we can take a material which is having the CBR value of 30%. Okay, now look at this. Materials available for base, CBR 30% and 80%. So just take this thing like that we have got two materials for the base. We are having CBR of 30%, CBR equal to 30% for one material, and CBR equal to 80%. So optimal thickness of each layer while minimizing costs are mentioned on the figure below. So look at this cross section. You can see that the total thickness, well, this is the subgrade. The total thickness of the pavement is 23 inches. Out of 23, 3 inches we are having the wearing surface. Top 6 inches, this one of base, is having the CBR value of 80%, and beneath that we are providing this material, and that is having the CBR value equal to 30%. So you can see that this one is having a thickness of 14 inches. So this is 14 inches plus 9, so you are having the total thickness equal to 23 inches. So same CBR of subgrade as before, so the total thickness is obviously 23 inches, and the materials available of CBR 30% and 80%. So to determine the optimal thickness of each layer while minimizing the cost, so we know that CBR of 30% needs minimum of 9 inches of pavement courses above it. Three inches of wearing surface, 6 inches of CBR, 80% in the upper 6 inches, and so 14 inches of CBR for the remainder of the base. So in this way we are having this cross section. Now look at another example. Given same CBR subgrade as before, so obviously the total thickness is equal to 23 inches. But here we are having the three materials available for the base: CBR 15%, CBR 30%, and the CBR 80%. Determine optimal thickness of each layer while minimizing costs. So obviously in this case 3 inches of wearing surface is required. Top 6 inches of the base will be meant for material having CBR 80%. So you can say 6 inches of CBR 80% in upper 6 inches. Now look at this. A CBR of 15% requires X inches above it. How can you get it? A CBR of 15% requires 15 inches above it. You can see here that the CBR value of 15, you are over here, and considering this 15 CBR and just move like this, so you are here, that is the curve of 40,000 psi, so 40,000 pound V load, and corresponding to that you are having this value 15 inches. So it means a CBR of 15% requires 15 inches above it. Now a CBR of 30% requires X inches above it. So how can you get it? By using the design curves again, and that is 9 inches. Look at this. This is the 30 CBR value, and you can see when you are going downward, so that is the 9 inches minimum, and that is the thickness. So you can see a CBR of 15% requires 15 inches above it. A CBR of 30% requires 9 inches above it. So you can complete this cross section like this. So you can see at the top the wearing surface, and the base course is consisted of 3 layers. Top 6 inches is having the CBR of 80%. Then we are having the CBR equal to 30%, and this material is having the CBR of 15%. Now look at this example. Subgrade of CBR equal to 7%, 50,000 pound wheel load for a taxiway. CBR materials available in this case 80%, 30% and 15%. Design the pavement with attention paid to optimizing cost and stability. Now here look at the wheel load, that is 50,000 pound. This is taxiway. So you can see that 40,000 taxiway curve is this one, and this is 70,000 pound wheel load for taxiway. So in between this curve and this, you will have to mark the curve yourself corresponding to 50,000 wheel load, and by using that you could be able to get the thicknesses of the constructions. So here the total thickness, that is 28 inches, that you will be getting corresponding to that curve. Wearing surface thickness is 4 inches because the wheel load is 50,000. By consulting that table that I have already discussed, you can get it. Upper 6 inches of CBR, that will be having the CBR equal to 80%. CBR of 30 of 7 inches, that means thickness above that material is equal to 10 inches. And the CBR of 15 of 11 inches, thickness above that material is equal to 17 inches. So you can get the thicknesses above that material of 10 inches and 17 inches by using that design curve, which is meant for 50,000 pound. And then you can draw this cross section and you can show the thicknesses of the different materials. At the top, the wearing surface, that is 4 inches. Then beneath that we are having the CBR, I mean to say the thickness of that base material, which is having the CBR of 80%. Then we are having the material which is having the CBR of 30%, and here this is the material which is having the CBR equal to 15%. So in this way you can see the thicknesses. This thickness is 11 inches, this thickness is 7 inches, this thickness is 6 inches, and the wearing surface is 4 inches. So in this way we have designed the pavement. Now just for the practice, look at this problem and you will have to solve it yourself. Subgrade of CBR equal to 15% and 70,000 pound wheel load for a runway. CBR materials available 80%, 40%, 20%. So design the pavement with attention paid to optimizing cost and stability. Now look at this one. As per Washington State Department of Transportation, the typical values of the CBR for different materials are given along with the elastic modulus. So you can see the crushed stone, in that particular case you are having the maximum values. So you can say this is the best material for the pavement construction. So here you can see the coarse grained soils and fine grained soil. As you know, these are the two main categories of the soils, and here the symbols are given and the CBR ranges are given. So again you can see that for coarse grained soil the values are higher. And if you just look at this slide, general rating of the material on the basis of California bearing ratio. Look at that. Very poor, poor to fair, fair, good, excellent. So when you are having 0 to 3 CBR value, very poor material, 3 to 7 poor to fair, 7 to 20 fair, 20 to 50 good, greater than 50 excellent. And the uses are also mentioned in this column. So here you can say this one can be used as subgrade, this one can be used as subgrade, this one can be used as subbase, and this one can be used as base and subbase both, and this one is obviously meant for base. And corresponding to these ranges of California bearing ratios, the classifications of different materials or soils are mentioned over here as per Unified Soil Classification System and AASHTO Soil Classification System. So generally these ranges are followed in the National Highway Authority, Pakistan. So in this way we have discussed the CBR method in detail. Thank you.